I'm Mark Sponsler, and welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, October 10th. Stormsurf, waves, weather, buoys, altimetry, snow, temperatures, El Nino, weather analysis, real data for outdoor people, all the time, no hype. Looking at significant wave heights for the North Pacific Ocean, we see an area of disturbed weather. We won't even call it a gale, producing 16, 17-foot seas in the northern Gulf of Alaska. But other than that, pretty quiet pattern, at least for the moment. But things are forecast to get a bit more active. As usual, we'll start by looking at jet stream level winds. These winds at about 30,000 feet help support the formation of gales, and when they develop, help direct their path. We're looking for a dip in the jet, a trough, just like right there. And sort of like right there. What that helps do aloft is create a counterclockwise flow. That's the hallmark of low pressure. It also manifests itself the same way down at the ocean surface. And low pressure, if it's strong enough, generates winds. Winds, if they're strong enough, generate seas. Seas, as they radiate away from the fetch area, eventually turn into swell. Swell, when it hits your beach, turns into surf. So, the trough is the beginning of all of it, so we'll start examining that first. We see a tiny little trough here, but it's mainly north of the Aleutians in the western Bering Sea, and a trough moving inland over British Columbia. And other than that, we see a ridge, the exact opposite of a trough. That helps support high pressure, and of course that doesn't really do anything for swell generation. Same thing here over the western Gulf of Alaska, high pressure. So, at least for now, the upper atmosphere doesn't look very conducive to gale development. As we get into Tuesday, a little very pinched off tight trough is forecast in the northern Gulf, but it's being driven by 150 knot winds. The stronger the winds pushing down in this southwest quadrant of what would be the low pressure system, the greater the velocity of winds in the gale and the better the opportunity to produce surf. So maybe a smidgen of hope on Tuesday, and then that all gets shut off. And then we get into Thursday, another kind of very, these aren't deep troughs. They're just very general, kind of weak-looking troughs. Another forecast for the northern Gulf. But then starting to get a bit more of a downward push while wind energy starts building off the Kuril Islands on Saturday. And then finally, as we get right to the end of the model, a legitimate trough is forecast starting to develop in the northern Gulf, being fed by, was that 1, 2, 3, maybe 3 or 4 shades of blue, so let's say 160 knot winds. So that looks like a semi-legitimate trough. The problem is it's 180 hours out. Never believe the model's that far into the future, but at least it's a tease. It gives us something, because as of now, we haven't had a whole lot in the North Pacific. All right, so let's go take a look down at the ocean surface, and not unexpected, we have high pressure, very strong, 1036 millibar high, filling the Gulf of Alaska. If there was a trough and low pressure being developed by it, it would be right up here. There is some weak low pressure, 1008 millibars versus the 1036 millibar high here. The difference between the pressure in these two competing systems is generating 25, almost 30 knot winds, targeting British Columbia down into Washington, maybe Oregon sort of thing. But all that would be just wind swell, like 9-second period wind swell. Another high pressure system building off the Kuril Islands, 1032 millibars. So no big hope there. Now, if you kind of notice, pretty strong winds forecast for North and Central California as we get into Monday. 35 knot winds, 35 knot winds along the coast. So that's pretty much just, you might look at the models and see swell for tomorrow, but it's just going to be a complete blown out mess. So unless you got some really secret tucked in corner somewhere, don't expect a whole lot. Other than that, we're watching low pressure systems, 2 of them as we get into Monday night. One in the Gulf of Alaska with 35 knot winds, another one over the dateline with 40 knot winds, and they continue east into Tuesday morning. Almost 45 knot winds in the northern Gulf in the first one. 35 knot winds continue on Tuesday morning. That all sort of starts fading as we get into Tuesday evening, all merging into one. And then even by Wednesday, that's all gone. Winds continue off the California coast. We'll get into that in a minute. The next opportunity we know is out like on Saturday or Sunday. Yeah, a little bit of low pressure is forecast up here in the Gulf on Friday, but again, you want to see at least 35 knot winds and preferably 45 knot winds. Then as we get into Saturday, we know there's a trough building here. You can see, now we saw the actually wind, we'll go back, up here, 45 knots, but it's north of the Aleutian Islands. No swell gets through the Aleutians, so that's a fish storm as far as we're concerned. It's not till we get into Sunday morning that fetch starts falling proper into the northwestern Gulf at 35 to almost 40 knots in pockets, and sort of building some momentum, it looks like, as we get into Sunday night. But again, that's a week out. We don't believe any of this, but at least it gives us some hope. All right, let's go take a look at the effect of those winds on the ocean surface. So we're starting off, we're looking at Saturday. Just a day ago, there was a little bit of low pressure that pushed through the northern Gulf, generating, says 22-foot seas, but that's 19,132. So that's over here somewhere. So we have to eyeball this. That's 18 feet. So we'll say 19-foot seas in the northern Gulf, building to 20 feet on Saturday night, and then to about 20 feet Sunday morning, fading, and then fading out from there as we went in through the day today. So maybe some little swell to result, but with the winds that are forecast off the California coast, whatever swell was generated is going to be buried in much larger, much rawer local wind swell. Probably no swell into Hawaii because it was all aimed. I mean, it's very tucked up here in the northern Gulf and all aimed mainly to the east. So nothing until we get into Tuesday. We know there's these pair of gales. What is that? We'll get to Tuesday morning. There we go. 22-foot seas, maybe 23 feet in both of them. So that's an opportunity for swell production. Some for Hawaii, better for the U.S. West Coast. Seas building to 26 feet through the day. But once you're up in here, I mean, the California, Northern California cutoff is somewhere like right about in here sort of thing. And the further south you go, the further the cutoff goes over to the west. So yeah, some swell result. Nothing particularly large, but at this point we're groveling. We'll take anything from the north. So now and then things go quiet. We're just whipping through this thing, looking for anything with, we'll say, we're lowering our sights. Give us 18-foot seas. Again, here's that 26-foot plus type sea thing, but all encased for the most part over the Aleutian Islands. It's not till we get into Sunday morning that winds really get exposed south of the Aleutians. We get 22, 4, 6, says 28, 20, 22, 24, 26, says 28-foot seas, but we'll say 27-foot seas right there, maybe 1 pixel at 28, and then about the same thing as we get through the day Sunday. The suspicion is, if the model is correct, that this might actually rebuild and get stronger than anything it was earlier. So again, we'll keep our eyes on it, but we don't believe it just yet. Of more interest, southern hemi swell currently hitting Hawaii. Buoys were pretty solid yesterday, peaked out yesterday, still pretty decent today. I mean, top spots were a foot, maybe 2 foot overhead. Best south-facing spots on Oahu. But this is from Saturday a week ago. Actually, the pulse that hit is from an earlier pulse of energy, so more swell to come. Swell is also it's supposed to be hitting California as of right now. Just looking at the Point Loma buoy, well, what's that, 0.7 of a foot at 20 seconds, so we'll say that's maybe pure swell when you take all this into consideration, maybe a foot or so, 1.5 feet at 20 seconds. Not even 1.5 feet, maybe 1.2 feet at 20 seconds. So, oh yeah, and actually it calculated pretty good. 1.4 feet at 19.2 seconds from 216 degrees. So there's some little swell in the water down there. Supposed to be building over the next day or two. Nothing huge, but certainly rideable. The big concern is the wind swell that's going to be hitting, certainly in Northern California, will probably swamp whatever there is of the southern, at least the leading edge of the southern hemi swell. So sort of just keep your eye on the buoys and play it by ear and see whether it's even worth the effort to go. Anyway, that system pushed across the central South Pacific, faded it out. A second pulse developed on Tuesday. That was Tuesday of last week with tiny area of 28-foot seas. And then it says 30-foot seas here, but they're all aimed southeast and of no interest. We'll blast through the rest of this. It's been quite quiet after that. And here we are at a current date. Literally nothing going on down south and nothing forecast for the next week. All right, wind swell. What's the situation going on? So we're looking at both Hawaii and Northern California. Solid high pressure, 1038 millibar high. That is bulletproof, driving wind circulate clockwise around high pressure. So you can see the fetch building here. We talked about this earlier along the Pacific Northwest. Also, solid trades, 20 knots or more pushing into Hawaii as we speak. East wind swell on east-facing shores. So we get into Monday. Here comes the wind machine. 30, 35 knot winds from, we'll say south end of Cape Mendocino the whole way to Point Conception. Wind swell probably will work its way down into Southern California. The most exposed breaks by later in the afternoon. Look at 35 knot fetch, even down to Point Conception. The whole coast just getting raked by it. Trades back off a little bit relative to Hawaii. You also see some fetch here. We looked at that earlier in the Gulf of Alaska. Looks better here than it did on the other charts, but that's only because we're zoomed in. Wind swell continues on Tuesday. 25 knot winds along the California coast. Trades down a little bit more moderate, 15 knots into the Hawaiian Islands. Get into Wednesday, things moderate a little bit more. Still some fetch off the North California coast, trying to rebuild to almost 30 knots there in one little pocket. Trades continue for Hawaii, so wind swell, more wind swell on Thursday for both Hawaii and California. So we get into Friday, things finally start letting up. That big, powerful high pressure system is gone out of the picture. So we got to survive Monday, Tuesday, Wednesday, and maybe a little bit of Thursday. And then we get into a much more typical pattern for this time of year. Lighter winds, much lighter winds, and just waiting for the storm door to open as we get into all the wind swell pretty much will be gone. That'll give us a clean canvas. So we get into Sunday, new broad low pressure. Again, starts building in the Gulf of Alaska. It's pretty obvious that if this all materializes, some swell could result for both California and Hawaii. Precipitation potential. We're looking at California here. Anything to get some moisture into the state, try to suppress the fire danger. So that we actually did get some snow, what was it, a couple days ago, up in the Sierra. A couple inches, 3 feet above the 8,000, 3 inches I said. Did I say 3 feet? 3 inches above 8,000 feet. But we just looked, it's almost all gone now. Temperatures were up in the almost 50 degrees, up fairly high today at Squaw Valley. Still pockets in the shadows, but that's all going to be gone. As we get into Monday, a little backdoor front is forecast ahead of as the high starts pushing in. It actually, because it's very dry air, any lingering moisture, it's sort of like, this will act like a dry bulldozer and build up all the moisture in front of it. So any little bit of moisture will wring out of the clouds. Maybe a half inch at Squaw to maybe 2 inches down at Mammoth, something like that. We'll look at that in a minute. But a dusting of snow again as we get into Monday. And then bulletproof, high pressure in control. Yeah, a little bit of rain here for Mammoth as we get in. Mendocino. Cape Mendocino as we get into Wednesday, and then it's just high pressure, dry air. We'll just literally nothing for California until maybe this system, but still that's a ways out. Maybe that'll give us some hope, but for right now, no immediate sign of any real precipitation for non-elevated areas in California. You wouldn't really expect it till about October 15th, somewhere between October 15th and Halloween's when we first get our first legitimate measurable rainfall. I think Southern California actually got some rain last week. Not a lot, but a bit. Up here, not a whole lot. And a quick look, we're just going to look at the snow. You can see the storm track is really into the Pacific Northwest, but here we go. Let's go back. Okay, Sunday evening into Monday, 10 a.m. Here's that little bit of, I guess you'd call it, dusting of snow in the Sierra into about 4 p.m. and then it's all pretty much gone. We'll blast through the rest of us. You can see the fronts coming into Oregon, Washington, not making it any further south than that, and then even dry. Whistler seems to be doing all right, and this goes out 240 hours, and then even after that, it's just bulletproof high pressure. No big unexpected surprise there. Snow forecast dashboard for Squaw Valley or / Olympic Valley, however you want to call it. Nothing really for Squaw, but I wouldn't be surprised if they got a ½ inch. It's really the snow level that we're interested in. Today, pretty warm, but temperatures falling as we get into Monday. Monday night down to snow level down, here we go, to about 4,000 feet maybe for a couple of hours, then building back up into the 8,000 foot range. And as we get into the 14th, 12,000 feet, and roughly holding in the 11 to 12,000 foot range beyond that. So a little bit of a cool down and then stabilizing back. Certainly not summertime, but certainly not winter yet. Sort of that perfect Indian summer type pattern that the fall in California is known for. All right, let's go take a look long term. What's going on with the Madden-Julian oscillation? That's that periodic weather oscillation that traverses the planet, active phase and inactive phase. The active phase on one side of the planet, the inactive phase on the other. They rotate around the planet on the equator from west to east. When the active phase moves over the Pacific, that helps feed energy up into the jet stream, feeds the storm track. You get more storms. And also, if it's strong enough, the active phase can help change trade winds on the equator that can then in turn produce things called Kelvin waves, which is basically warm water transported from the West Pacific to the East. Successive strong active phases of the MJO can usher in El Nino. Of course, that is not the case right now. And then, of course, ENSO, the El Nino Southern Oscillation. That gives us our real long-term forecast, looking out a year or two. We'll get into both those right now. All right, so first off, we're going to look for any signs of the active phase of the MJO, and we're going to look at winds. That's the arrows on these charts. This is the equator. This is the East Pacific here. This is the West Pacific here. The arrows depict 5-day average winds. The longer the arrow, the stronger the wind. So pretty strong east trades over the East Pacific, pretty strong east trades over the Central Pacific, and the Kelvin wave generation area, this West Pacific area from as far west as you can get, about 135 east to about 170 west right there. 5 degrees north and south of the equator. That's where we're interested in, right there. And trades pretty strong out of the east, but it's not the actual trade winds. It's the anomalies, the difference from normal for this time of year. Yeah, winds tend to blow pretty strong at certain times of the year. And, is it stronger than normal for this time of year or weaker than normal? That's what helps define the active phase of the MJO. So looking over here in the far West Pacific, the arrows are for the most part out of the east, so they are blowing stronger than normal out of the east. Enhanced trades, that would be, okay? In the Central Pacific, again, arrows out of the east, enhanced trades. In the far West Pacific, also enhanced trades. So this would be a sign of the inactive phase of the MJO. The active phase would suppress these trades, or at least give you no arrows, if not changing the arrows from east to west to east. So right now, it looks like the inactive phase of the MJO is in control, just eyeballing it. Let's go look at the forecast. So here we go. This is 850 millibar zonal wind anomalies. Just fancy words for, is the wind blowing harder out of the east or harder out of the west? We want to see west winds, not east winds. Okay, the blues are east winds. The reds are west winds. All right, so where are you? This is the whole planet on one chart. The date line runs right up the middle. Okay, well, we know the date line's over the Pacific. Far West Pacific starts about 135 east, so right there. Okay, California's at 120. Ecuador's about 80 west, so somewhere right along there. But the Kelvin wave generation area, that's the part we're most interested in. So 135 east to 170 west. So a box right in here. Unfortunately, what do we see? Well, the thing that really catches your eye is we've just had this steady, incessant easterly winds. It looks like the inactive phase of the MJO, but it might not even be that. It's just steadily stronger than normal east winds since way before September, blowing, and forecast to continue for the next week. Each tick mark here is a day, so this is only a week out. Now we do see westerly anomalies. They're trying to make their way into the Kelvin wave generation area, so that would suggest, well, maybe the active phase of the MJO is in control, but not for long, for maybe another 2 or 3 days, and then it just gets beat back, or at least the westerly winds associated with the active phase of the MJO. Let's keep digging. All right, so outgoing long wave radiation. Fancy words for, is there more sunlight bouncing off the ocean surface than normal? What's that mean? Well, if you have a lot of sunlight bouncing off the ocean surface, outgoing long wave radiation. Sunlight hits the ocean, bounces off, is reflected back off the planet. If you have more sunlight, that means there's less clouds, right? And less clouds mean high pressure, and high pressure means the inactive phase of the MJO. All right, and yellows and oranges are more sunlight reflectivity, but no, we have negative anomalies. That must mean there's cloud cover here. That must mean the active phase of the MJO is in the far west Pacific. Okay, that's a good sign. That for the statistic model. Oh, let's get oriented. I'm sorry. 5 panels here. Each panel, 4 panels. Each panel 5 days long. Here's the equator, South America, Central America, Hawaii, Ecuador, the Philippines. Kelvin wave, oh, dateline right there, 180 west. So Kelvin wave generation area, right in that area. That's where we're interested. This says active phase, the statistic model, which this is over the active phase. The active phase is over the Kelvin wave generation area, and forecast to hold for the next 15 days. That's good news. And the dynamic model, the GEFS model, pretty much says the same thing. Active phase fading in the next, 10 to 15 days out. So that's pretty good news. Phase diagrams. This is just an amplification of what we saw before. This is the statistic model. This is the dynamic model. The MJO moves from west to east, from the Indian Ocean, over the maritime continent like Bali, over the West Pacific, over the East Pacific, under the United States, across the Atlantic, over Africa. We've been saying North Africa, but I went and looked. It's really more like Central Africa, back to the Indian Ocean. The heavy dot is where the active phase is today. So starting to sneak its way into the West Pacific. These are the 3 different projected strengths and paths of the active phase per the statistic model. The further the dot is away from the circle, the stronger it is. So if it's way out here, it's strong. So we'll say weak to maybe modest active phase. And according to 2 of the runs, it collapsing over the West Pacific 2 weeks from now. One says maybe modest over the West Pacific. The dynamic model says no, same thing as these 2 runs, collapsing in the West Pacific 2 weeks from now. So whatever active phase we have, it's at its peak right now and is supposed to only get weaker. Another trait or characteristic of the active phase of the MJO is it produces precipitation, right? So this is upper level moisture chart. 8 panels. I think they're each 5 days. Yep. Okay. South America, Central America, equator, right there. See the equator running through, we'll call it Central Africa. North Africa would be up there. Okay. There's the Philippines, New Guinea. Equator right there, dateline roughly right there, Kelvin wave generation area right there. Greens, moisture, active phase of the MJO, moving over the Kelvin wave generation area through the 20th of this month, then moving across the Pacific and into Ecuador about November 4th. Inactive phase, dry air, the oranges and the yellows, coming in behind that, making its path across the Pacific through the end of the model around November 19th. And then, right before Thanksgiving, another active phase working its way into the West Pacific. So you sort of see active, inactive, active phase. During the active phases, so somewhere in the next 10, 15 days, that would be a good opportunity for storm production. Then this window in here, we'll say like Halloween to mid to late November, not so good. And then again, the window opening up around Thanksgiving. So then let's look at this other model. This is the CFS model. This goes out a month, but it also overlays a couple of other things. It has the east-west component of the wind. It also has the active-inactive phase of the MJO. And it has this thing called a high and a low pressure bias. So let's get oriented again. Whole planet on one chart, date line runs right up the middle. Kelvin wave generation area, far west Pacific, starts about 135 east, so right there. Here's our current date, begin the forecast. Okay, so the blues, again, are these easterly anomalies associated with what we were saying was the inactive phase of the MJO. But then you see this solid this is the active phase of the MJO. And you see westerly anomalies building, pushing into the West Pacific today, continuing for maybe a couple of days. And the active phase continues across the Pacific, but when it gets to the date line, the westerly anomalies associated with it just get completely wiped out, and they don't redevelop again until the active phase gets over maybe south of Hawaii, something like that, and then continues. Okay, then behind that you see this dotted contour. That's the inactive phase. The next inactive phase coming across, easterly anomalies building strong, and then continuing across the Pacific. And then another active phase, not even making it into the Pacific yet because this is still early November, but queuing up the next round. So what's going on? You do see this purple dotted line here. The dotted line is a high pressure bias, okay? And that is the La Nina signature, well entrenched in the atmosphere, so strong that even when the active phase tries to push across where the high pressure bias is in control, it completely basically just vaporizes the active phase, at least the westerly winds, and that's the ground truth. We need wind on the ocean surface, westerly anomalies, to transport warm water east and impart energy into the jet stream. It barely makes it into the Pacific. The high pressure bias just destroys the active phase, at least the wind component of the active phase, and that's all she wrote. Okay, and same deal probably will happen in here. We'll have to see. All right, let's keep going. All right, same model, only this goes out 3 months, and the forecast is up here at the top. What has happened in the past is down here in the bottom. Date line running right up the middle. In general, Kelvin wave generation area right in here. What you do see is blues, easterly anomalies in control, and we're out into January. But we do see westerly anomalies, so here's the current westerly anomaly thing. We'll call this the active phase of the MJO. And then it's supposed to die off, and then it's supposed to make another push into November, into Thanksgiving, maybe even further and a little bit stronger into January. So maybe this gives us a little bit more hope. Now, this model 3 months ago was forecasting a strong active phase taking over the Pacific in the October timeframe. The active phase that has finally arrived, the reality of it is something far less than what was forecast months ago. Let's just overlay it. So here's that active phase. I mean, it looks pretty good. 3 contours moving from west to east, but it's just not capable of overcoming, and we'll get into this in a minute, what we believe is the high pressure bias over this area, just stomping on the any westerly anomalies associated with it, which really will severely limit its ability to impart energy to the jet stream and therefore generate storms. Another inactive phase follows, but it's interesting. Westerly anomalies are supposed to start building as we get in November. There was a stronger active phase forecast in this. The model keeps jumping around, unsure what's really going to happen in this time frame. But it has consistently been showing these yellows, these westerly anomalies, getting a much better footprint in the North Pacific. That would be really good news. I mean, that would sort of suggest that maybe the high pressure bias here is fading. Let's overlay the high pressure bias. So here it is, dotted contour, right on the date line. It started back in early September. That's what's building these easterly anomalies. Second contour line forecast in about a week, continuing into about early December. Then it fades. Also notice the extent of this high pressure bias starts moving off to the east. Also notice the low pressure bias, which is forecast to develop in October, late October, over the Indian Ocean, is forecast to start making an incursion into the West Pacific. So if the Pacific starts there, just eyeballing it, somewhere around here, about mid-December, and getting a better footprint in the Pacific after that, still in the far West Pacific. So this would be our window where we'd think if so this is the La Nina signal, this high pressure bias. And it sort of looks like La Nina is going to weaken and start pushing off to the east and fading as we get deeper into January, still controlling a good amount of the Pacific. The other thing is California is right here, and you see easterly anomalies in control of California the whole time. That might cause, it's actually south of California, but that might significantly impact the amount of rainfall we get as we get deeper into winter. No big surprise. The real hope is we were hoping that La Nina would not return, or it'd be sort of a faint image, a ghost of what it was last winter. Unfortunately, that does not seem to be the case, and we're going to get more into that in just a second. All right, so let's take a look down in the ocean. This is the West Pacific here, down 500 meters. It's like 1,500 feet. This is the East Pacific, same thing. And these lines are contour lines, thermocline lines. 28 degrees, this is the 28 degrees Celsius line. This is warm water. There's the date line. All balled up in the West Pacific, the 24 degree Celsius line, making it to a point about south of California, 125 west. This is on the equator only. And then the, and the 20 degree isotherm pushing into Ecuador, but really you get the sense that warm water is all confined to the West Pacific. This is actual temperatures, 5-day means, but that's good enough for our purposes. But it's the anomalies, differences from normal for this time of year. That's what really tells the story. You see 0 to 1 degree Celsius centigrade temperatures above normal confined to the far West Pacific. Where's the date line? 180 west, so 170 west right there. Not making it anywhere much past 170 west. Instead, we have cold water, 3, almost 4 degrees below normal, filling pretty much from the date line the whole way into Ecuador at depth. That is not good news. Let's look at another model. But before we do that, notice, so these X's here, these are the anchor lines on the TAA buoys. The X's are sensors. So there's a big gap in the sensors here. And they use a model to go and fill in the gaps where there aren't data. So the model's sort of guessing what's going on here. But we can look at another model that it's using more than just these sensors. It's more of a comprehensive view, a holistic view of other data in the Pacific. And this tells the picture much more strongly. Again, warm water building up in the West Pacific. Cold water in control of the East Pacific from 170, just about the date line, entirely the whole way east, pushing up towards Ecuador. Kelvin waves would be if you saw this warm water starting to form a finger and then making a stream the whole way across the Pacific up towards Ecuador. We don't see that. This warm water is being held at bay. Why is that? Well, trades are blowing stronger than normal from the east to the west, this way. There's no chance. There's lots of upwelling going on here. The sunlight can't warm the surface waters because the surface waters are moving too fast off to the east, just pushing all the warm water into a ball over here in the West Pacific. And it's just a steady upwelling machine of deep, cold water working its way up to the surface of the ocean. That's the hallmark of La Nina. Now here's a satellite view of what's going on. This is not sea surface temperatures. This is the height of the ocean, literally, and down to the adjacent satellite, I think is accurate to like 2.5 centimeters or something like that. Hard to believe, okay? But it passes over the Earth polar orbit about every day and a half, 2 days, something like that. It gets a complete mapping of all the Earth's surface. And then they strip away the waves, strip away the wind waves, strip away the tides, and you can just see whether the sphere of the ocean is higher or lower than normal. What you see is below normal, minus 20 centimeters over a good size area here. This is the equator. Okay, there's the date line. South America right there. There's the Galapagos. Central America, Hawaii right there. Okay, and then the Philippines over here and New Guinea. Okay, on the equatorial Pacific, that's all that matters. 5 degrees, so there's 10 north, 10 south. 5 degrees north and south of the equator. This little band right here is everything. Okay, and the ocean's surface is lower than normal. Well, what's that mean? Well, if you have strong east winds scooping out water and pushing it over here where the heights are 15 centimeters, 10, 15 centimeters above normal, that says literally it's like a bulldozer scraping the ocean surface, pushing it this way and holding it there. Also, cold water at depth contracts, right? That'll create a divot on the ocean surface. So what this is saying is there's cold water, really cold, minus 20 centimeters in difference height over a large area of the Pacific. So there must be some really cold water at depth there. Likewise, the heights here, warm water expands, get a big bubble on the ocean surface. So last year, I think this got down to maybe 15 and not even over as large of area. So this suggests that this year's La Nina, we thought last year was bad, but this year's La Nina looks almost worse than last year's. Not good. Upper ocean heat anomalies here. This is the West Pacific here, East Pacific here. And you have time. We're going back last year. So around Halloween last year, here's the peak of the cold water from last year's La Nina. You can see where it's at. Where is that? About 140, centered about 142 west and over that area. And cold water well into Peru and Ecuador, that sort of thing. Continued, though slowly faded into February, and then Kelvin wave, warm water, moved across the Pacific in February, another in April, another in June, and then they died. And after that, here we go again. East anomalies pick up, and we have our cold water pool at, now this is subsurface, 141 west versus about the exact same position as last year. But notice cooler water over here last year as compared to this year so far. And the more westward extent, the cool water moving to 175 west, where last year at the peak we weren't anywhere close to that. Later on it moved that way, but we're sort of thinking that maybe, at least subsurface-wise, the center of the cool water is a little bit more westward displaced than last year. And that's kind of what we want to see. We want to at least have some sort of an opening for backdoor fronts to push down British Columbia, down the coast, into California. Anything to get some moisture in. Wherever the center of the cool water is, now this is subsurface, this isn't at the surface, that's where the center of bulletproof high pressure would be, right? If you have cold water on the ocean surface, you cannot get evaporation. If you can't get evaporation, typically what happens is high pressure forms right over that. So just keep that in mind as we dig a little deeper here, especially on the surface ocean surface analysis. All right, so here we go. Sea surface temperature anomalies. This is surface, not down in the ocean. Before the down in the ocean thing we were looking at was about Kelvin waves and, you know, is there potential for Kelvin waves and what's going on subsurface that might give us a clue as to what is going to happen, and what we see is nothing but cold water. We look at the ocean surface. All right, so South America, Chile, Peru, Ecuador, Central America, Baja, Hawaii, where is it? Up there somewhere. Can't really even see, right, can't see it. But anyway, you get the general idea. Date lines out here. What you see is blue is cold water. Cold water off Ecuador, the Galapagos, but even more of it. Oh, there's Hawaii. Sorry, I was just not looking in the right place. Anyway, lots of cold water south of Hawaii from the date line pretty much to about a point south of California. Yes, there's cold water here, but volume-wise, especially look south in here, really the focus of the coldest of the cold water appears to be south of Hawaii, at least in this view. Let's continue on. Sea surface temperature trend. Now we do see the blue, and it's just on the equator we're interested in, just in this area right here. And blue is cold, or not cold water, it's water getting colder. So we see building cold water from Ecuador out to a point south of California, and then even out to a point south of Hawaii. So whatever we're talking about right now about cold water being limited more to the point south of Hawaii. Maybe take that with a grain of salt. We have to see what's going to happen out here over the next couple of weeks. But for now, our thesis is that the surface cold water is a little bit more westward displaced than last year. Here's the view right now, just the macro level view. You can see it seems the intensity is like right in here. Not so much here, but it's we're sort of splitting hairs because it's cold off of Ecuador the whole way across the Pacific to the date line and beyond. This looks like a stronger La Nina than last year. In fact, let's do a quick little bit of a look back. Right, so here we go. Here we'll pull the date right in there so you can see that. And I'll pull myself out of this a little bit. All right, so July 1st, 2020, building cold water developing. We're just going to put this into motion. It's 1 month intervals here. Maybe this will stay. Why does it keep jumping? All right, well, you'll see this is September, October, November, December, January. But let's go back. Right about there was the peak of it, November, and the core of it was between 120 and 140. And we didn't get a whole lot of precipitation last year. All right, now we're going to continue forward. December, and then as we get into January, look, it's all of a sudden, boom, warm water shows up off of Ecuador, and the La Nina pattern appears to be rapidly fading. We're into April, we're into May, into June, and all of a sudden, hey, it looks like La Nina is over. And then all of a sudden we get into August, and here comes that cold water pattern again. And now we're into October. But notice, in October, and this is the most recent one, this is October 1st, the bulk of the cooling is out here in October, okay? And maybe we can, and here's October from last year. So it's we'll just blast through it again real quick. And here we go. Oops. Cancel. There we go. Okay. You see a different sort of setup this year. Again, this is what's making us think that maybe this year it's going to be a bit more westward displaced. Not so much in here. This area of warm water has held steady for, well, we'll go back through and we'll just see. It's been there pretty solid since, well, these are 1 month intervals. So here's March, April, May of this year. I mean, it's been holding pretty good. The question is, will it hold here? And will the core of the cooling be out here? If so, then that means that's where the core of high pressure will be. And so storms pushing off of here this winter will ride over the high. Then they'll fall down the coast. And we're not even talking about surf here. We're just looking for any kind of precipitation into California to try to do something to help fill up the reservoirs a little bit. So that's our quick analysis. Actual sea surface temperature trends is in the Nina 1.2 region. This is the area on the equator right there by Ecuador and Galapagos. Temperatures today, 3/4 of a degree below normal, 760 thousandths of a degree. This is not an official El Nino monitoring region, but 1/2 degree below normal for 5 consecutive months is the water temperature indicator for La Nina. We are in that range. We have been in that range since August. The official El Nino monitoring region, the Nino 3.4 region, so this is the area south of California out to about the date line on the equator. We've been, 0.2 of a degree below normal. But today we're down to 631 thousandths. So just 1/2 degree is the cutoff, where you start getting into La Nina. So officially, water temperature-wise, we're just since September 26th getting into La Nina territory. But clearly, again, looking at that historical view, we've been predisposed to be, the atmosphere is pre-primed for La Nina. There is no doubt about it. We had our 3 Kelvin waves this summer, and as soon as they shut off, it was pretty clear we were going back to La Nina. The question is, how deep is it going to go? All right, so what's the atmosphere think is going on? We've looked subsurface. We've looked at sort of the Kelvin wave situation. We've looked at the MJO and what's it doing or what's it not doing. I mean, it's trying to be It's trying to do something. The active phase is trying to do something, but it just hits the Pacific and it just gets blunted out by the high pressure bias over the date line. We've looked at the ocean surface. Yeah, temperatures are cold and getting colder. And now let's go look at the atmosphere above, see if we can get some clues there. All right, so Southern Oscillation Index, difference in pressure between Darwin, Australia, and Tahiti. Tahiti's over the Pacific, Darwin's over the Indian Ocean. If pressure is lower in Tahiti, the index goes negative. Hey, today it's actually negative, minus 4.13. But you look back day after day, oh, we were up at 36.9, a couple of negative readings, but by and large, it's been positive, clearly indicative of at least the inactive phase of the MJO. Okay, and La Nina really is just a preponderance of the inactive phase of the MJO. El Nino is a preponderance of the active phase of the MJO over the Pacific. All right, but let's take all the noise out of here. 30-day average SOI plus 10.77 and pretty much holding steady for the past month. So we're not getting any worse, but we're not getting any better. The 90-day average. So this is our inactive active phase sort of indicator. This is our El Nino La Nina indicator. 9-day average 9.32. And what's it been? Not really changing a whole lot. So that's kind of good news. It doesn't appear atmospherically that La Nina is getting any worse. But typically, it's not till somewhere between Halloween and Thanksgiving where you really, for La Nina, where you really see the peak of it. And El Nino is more like December 15th kind of thing. So we expect this to get a bit more positive before it starts dropping. All right, let's graph the 30-day moving SOI value. Today, we're right, what did we say, 9.7 or 10, somewhere right around in there. All right, but you can see back in time. 2019, we were negative values. We were in a weak El Nino sort of, or at least an El Nino bias situation. The downward spikes are the active phase of the MJO. The upward spikes are the inactive phase. You can see the downward spikes, by and large, were more prevalent, especially that one there, than the inactive phase. But then we got into like early 2020, and all of a sudden, the inactive phases started taking over, being more prevalent, and all of a sudden we were into we were into October of last year, and we were positive right around 10. We got one value up to 20 there right around early January, and then again, active phase of the MJO started taking over till July. We got our Kelvin waves, and now we're back riding the upward trend. The question is, so for October last year, we were right at about the same place we were last year. Are we going to go higher, or is it going to be the same? Unknown. Guess we're going to see. All right, so here's the projection from the CFS version 2 model for Nino 3.4 sea surface temperatures. This is the official El Nino monitoring region. So last year, October, this is over a broad area from 120 west to 170 west, 5 degrees north and south of the equator. Temperatures drop down to 1.25 degrees below normal. So sort of a mid-grade, moderate La Nina. And then in the summer, temperatures almost return to normal. Here we are today. Well, actually, this is mid-October. We're probably somewhere around here. The model suggests, and right now temperatures are, what we saw, is about 3/4 of a degree below normal. So this is about right on track. This model shows temperatures going down to, at least this version of it, down to almost 1.9 degrees below normal. That would be a mega La Nina. We don't think that's going to happen, and even the modelers know that's not going to happen. They have here you go, the sneaky version here, the PDF corrected, and that suggests temperatures going down to 1.5 degrees below normal, so a little bit colder than last winter. This might be a little biased even low, but still, the thought is right now that the La Nina that we're heading to this winter is going to be at least as bad as last winter, if not perhaps a little bit worse, but the position of it where the core of the cold water is key. All right, so for right now, small southern hemiswell is hitting Hawaii. I mean, it's rideable, pretty nice. And that swell is starting to tickle the buoys in Southern California and will work its way up into California. Unfortunately, a bit of wind swell, and that's sort of an understatement, is expected tomorrow and maybe into Tuesday. So that will sort of mar some of it, but maybe we'll get a couple days out of it. I think the swell's supposed to hang around till Thursday. So there's some hope there. Beyond that, it looks like the jet stream is going to try to get a little bit more productive starting next weekend. So maybe there's some hope, not completely sure, but maybe. So the North Pacific will wake up a bit. Longer term, clearly we're into La Nina. Clearly we can sit here and have the debate, but the current thought is the La Nina that we're going to experience this winter, and it's a for sure, is going to be at least as strong as what we got last winter. Is it going to be stronger? We're hoping not. We're thinking probably not, but you never can be quite sure. The key is the position, the core of the cold surface waters. If they're south of Hawaii, I mean, that's not good for Hawaii, but in terms of precipitation for California, that offers in some hope for those backdoor fronts. Whether that happens or not, it's anyone's guess. It's way too early. The models clearly don't have a complete handle on it. The CFS model has been predicting this big westerly wind burst taking over the Pacific and La Nina sort of fading out by about now. All of a sudden now that model is rethinking that position, saying, well, maybe not, and clearly pretty much looks like La Nina is here. So our one hope, and I'm kind of just, it's a hope, I'll just say it flat out. We're hoping the core of the cold water is westward displaced so that it opens the door for backdoor fronts into California. Otherwise, we're going to have some significant water problems as we get into next summer. Let's hope that's not the case. All right, so that's the video for this week. If you liked it, give us a thumbs up. We'd appreciate it. Comments always welcome. If you haven't subscribed, please subscribe, ring the bell. If not, go to stormsurf.com. Links to the video are posted on the top of every page on the site after we post the video, and you can watch it at your leisure there. Video should be presented next weekend. We might not be available, so it's going to be hit or miss, but with La Nina being the way it is, things probably are pretty stable. We'll see how it goes. We're going to make every effort to try to do it next weekend, but no promises there. All right, so that's it for this week. Go surfing if you can. Get some waves. Stay safe and pray that La Nina either isn't as strong as it's forecast to be or is westward displaced so that we get rainfall in California. All right, take care. Be safe. Good night.